So now we get to officially start chapter 2. So we've already done some little parts of chapter 2, but we're just going to now go through 2.1, 2.2, 2.3, 2.4, and 2.5. 2.1, we are going to talk about increasing, decreasing, and piecewise functions, and we've already done the applications part, thank goodness. So when we're talking about increasing, decreasing, there's also this part called and constant functions. It's referring to what the y values are doing over specified x intervals. In other words, when a question says determine the intervals over which the function to the right is increasing, you're looking for what x values give you an increasing y values, right? So if I look at this graph is made up of 1, 2, 3, 4 pieces. And what's happening is that in this piece here, what are the y values doing? I go from 0 to 2. Well, they're increasing. In this second section here, what's happening to the y values? Well, it's always 2, so they're constant. From here, they're going from 2 to 4, so they're increasing again. And then lastly, from here to here, the y values are decreasing from 4 to -2. Now, when I ask you the intervals, I can see that the y values are increasing, but I want to know what x values are giving those increasing what x values are giving you those increasing y values. That's feeling like a weird sentence. So if you look here, over this interval here, so in section 1, these x values, the y values are increasing. So from -4 to -2, the y values are increasing. Now we always use round brackets because at -4 and at -2 there can be a change, and so we never say anything as a square bracket. Then in section 2, so from -2 to 0, what are the y values doing? Well, they're constant, so we put that here. So over the interval -2 to 0, the y values are constant. And then from 0 to 1, those y values are increasing again, so we would go or 0 to 1, they are increasing. And then lastly, from 1 to 4, so we had this little interval, right? We had this tiny little interval, and then we're looking from here all the way to here, the y values are decreasing. So from 1 to 4, oh, sorry. Of course I didn't write them in the order they came in. So they were constant from -2 to 0, because we're all probably screaming at the screen. And then lastly, from 1 to 4, the y values are decreasing. All right. Last thing here, I just want you to try one. So when you look at this picture, determine the intervals, so the x values, on which the function is increasing, decreasing, and constant. So let's write those down. Increasing, decreasing, and constant. Pay attention to the order you write them down in. Okay, so let's look at this part first. So from -infinity, so way over here, to this point here at -1, what are the y values doing? Well, they're constant. So we're going to say from -infinity to -1, the y values are constant. And then in the next section, we've got from -1 to 1 here. What are the y values doing? Well, they're decreasing. So -1 to 1, the y values are decreasing. And then our next section here will be 1 till, my eyes are playing with me, 4? Yeah. From 1 to 4, what are the y values doing? Well, they're increasing. And then the last section here is from 4 to infinity, and the y values are decreasing. Now I've been using the use because that means or. I just looked in the back of the book. They've just used commas just to list the intervals over which it is increasing or decreasing or constant. And so we'll just use a comma. And so we're going to go from 4 up to +infinity. This graph is decreasing. Now, just a couple follow-up questions on this one, just to lead us into what we're going to do next. Why does this graph have an open circle? Why is this here? Well, because if it didn't, it would not be a function. So the graph has an open circle because this is a graph of a function. It says on which the function is. So there's an open circle because there's a closed circle beneath it. So what should we say? Why does the graph have an open circle? To maintain being a function. I'll probably come up with different wording over that over the years. And the second thing is, well, what type of function is this? Well, it's not a type of function. So you know how we talked about our 7 to 8 base functions? You know, we've got a constant function in here, we've got a quadratic function in here, and we've got a linear function here. So it's actually made up of a constant function, a quadratic function, and a linear function. And since it's made up of these different pieces, we call this a piecewise function because it's not all one. And that is exactly what we're going to be doing in the next lesson.